So in this video we will learn about the check sheets. So while you are delivering your part to the customer, so that time you need to check some points. So that will be the agreement between you and your customers, because that points are really important for you and for customer also. So one thing that you should know, while you are going for a CAD test, you will get this kind of surface. Suppose you are going for a plastic interview. So before starting this model into converting into plastic, okay, so what you need to know that these cutouts, okay, this should not be on the A surface, okay, so you have to modify this surface like this. I have discussed in detail in A to B section, okay. So just hide this, so this will be your surface. So what are the various check that required on the seat? So let's take this part into the assembly. Okay, so this is our assembly, and here this part is going to be fit. So as individual part, what we need to check, so the manufacturing element like tool analysis, okay. So first of all we will check about the draft analysis, okay, at how much degree this is going to be clear, and then B side feature, at what degree that feature are going to be clear, okay. How we did that, that I discussed already, okay, inside the course. This is our analysis menu. So basically we check cover all plastic for 7 degree from main tooling. So here I'm checking this at 6.98, means that is 7 degree, okay. So you can see this is looking blue, only two color will come, okay. This green color is showing, color code is given here, you can check here what is the meaning. So according to this, this is not the meeting the requirement, so it's under 7 degrees, so we can check it at how much degree is coming. It's 4 degree. So suppose you need to check with your customer, okay. If I say that this area, this may be not visible area, so your customer will be agree. You can see this area may be going inside with the seat, okay. This is actually biting area, and some other checks, what are theirs? So like check kinematic seat guidelines. So while you are delivering your part to the customer, okay, you have to check this part all over its motion, okay, rear motion, okay, when seat is going to the back side, okay, coming to the front, coming to the upper side, okay, is there any interference, or what are the gap and flush issues, okay. So next point is our design for serviceable. You need to check your design is serviceable or not. Suppose if we are using snaps, okay, 1 minute, let's take it like this, keep in this mode. This is actually your physical part. When you get your physical part, this will be the real condition, okay, for your part. In this mode you can see there are a number of lines, okay, tangential, micro tangential errors, that are not the error actually, okay. So in this mode you will get your part properly. Is there any error? Okay, you will get it. So we were here. So heat stakes you need to check, okay, if you are applying some heat stakes, okay. We were discussing about the serviceability. If you are using the snap, hook feature, okay, and screwing, that mean your part may be serviceable, but you need to keep in mind that what are the entry angle and what are the exit angle for your snap, okay, that need to keep in mind, so our snap will come out easily. So then you can say yes or no, your part is serviceable or not. If we are using heat stakes, okay, that will be the permanent, your part is not serviceable, okay. Once it will be detached, you can't use that part again. So next is our attachment with screw. Okay, you need to check, suppose we are using screwing. Okay, so in that case, first you need to check your tool access, okay, with the environment. Okay, is there any interference with the tool, some anything you are using, the gun or something else, and dia for your screw, okay, and which screw you are using, and what is the thickness for the plastic at this area, so that your hoop stresses will overcome to the hoop stresses. Okay, then snap feature guideline. Okay, if you're using the snap, then you should follow the guideline whatever the company is providing. Okay, part to part interface. Okay, suppose if we are using one more part is there. Okay, suppose back panel will be there in at the back side, or inner cover will be there. So you need to check the part to part and what are the conditions. Suppose if I'm taking section in this area, so it will look like this. Okay, and some other part this will be like maybe coming like this, inner part. Okay, so these interface you need to check, is there any interference, gap and flush. Okay, this will be the gap, and this will be the flush. And then boss design guideline. Okay, same what we discussed in screw, that that should be according to the your rules whatever you are designing in your firm. Okay, then boss and locator design guideline. If you're using the locator, 99% we have to use the locator. Okay, so sometimes there will be assembly, it's very difficult to assemble the parts. Okay, so that time you need to do that. Then seat belt interface area. Okay, so you need to check, suppose your belt is coming here. Okay, you need to check that is your seat belt is interfering with this part, and how much we can keep the interference. Okay, then dog house. Okay, but there are some guidelines for dog house. And then we need to check the mold flow. Actually this mold flow that is done by the supplier. Okay, that is not your part if you are working for it as a designer or a product engineer. Okay, but you should know the mold flow, the basic things. Okay, how my mold is coming. Okay, is there any mold flow errors. Okay, basic thing you can check. And then your weld line, that weld line also depend on the mold flow analysis. Okay, then scan recommend, suppose if you are using the screw, and are you using tool gun, then do you have access to that tool gun. Okay, and shut off angle if you are using. All these things you need to fill in your check sheet whatever the customer will provide you. And there will be number of check sheets point around 50, 60, maybe some companies having 30. Okay, so that all need you need to be check. Okay, suppose okay, this is my part. Actually not whole environment is not there with this part for now. Okay, we need to pull that environment also. So I have completed this part, one of my student completed. Okay, this is screw, this is your main body. Okay, if I define this, okay, so this is the scenario. Okay, hide the surface, and this is the complete design for this part. Okay, so what he is using, and accordingly we discuss. Okay, so according to the frame we have to design our feature, but basically for this part what we are using, some hooks, snap hooks, locator, guide curve. Okay, fixation we are using here, that screw you can see, screw we are using here. Okay, that is not a good condition. I think that we need to check this dia. So this is 9, I think this is okay. Okay, but still the depth is huge, but we can use this much of dia, means 80 for tool access. This is for, this feature is for wire holding features. Okay, for hooks. And this is your front tab, and then ribs are providing here. If we check on the root thickness for this, let's check it, how much root thickness is coming. That is also very important, so that our sink marks won't come. So here the minimum you are getting 0.92. So actually this is good condition. The 40% of the sink marks is coming. Sorry, not sink marks, the root thickness is coming 40% for the plastic part, because my part thickness is 2.5 mm, as you can see. So we have to, if we are using here the PP material, then you should know the how much root thickness you have to take on. Okay, so this vary. So these ribs are providing the strength, and we have provided here, see, this cutout. Okay, no ribs is here, so we are using here the lifter. Okay, while ejection into the mold. Okay, this will be our lifter rod, and what will be the moment accordingly he has taken this. Okay, this area will be blank, so this will be clear from the main tooling also. Okay, for this feature or this feature also need to be clear from main tooling, not main tooling, with the lifter. Okay, and suppose this is visible area. Okay, so this is my power side shield, so this screw is visible, so this is not okay. But suppose we are using here some handles, like suppose this is a manual. Okay, and we are using a recliner handle here, so in that case we can take this, because this part that is coming here, that with the help of this screw will be hide, so this will be okay sometimes. Okay, so this will be for power side shield, sorry, for manual. But as we know from what we receive from the input, okay, this kind of input actually will get from the customer, not this kind of. Okay, what we check in a surface. Okay, this surface, so when you are going for the CAD test, this will be your input. Okay, so that time you have to fill all the, not fill, you have to use proper commands. Okay, so if we check which side shield it is, okay, so we can say this is our cutout for sheet belt. Okay, and this is for our lumbar mechanism, and this is for recliner, and okay, up and down, these two switches will be there. Okay, so for more detail we will discuss in A to B. Okay, so keep watching. Thanks.